Smartphones make it convenient to check email, news, and most importantly, to stay in contact with friends and family. It may seem strange to some these days, but one way to stay in touch is to actually meet someone outside the internet or telecommunication networks. Fortunately, smartphones can also be used as a navigational aid. Mobile applications provide easy directions when traveling in a personal vehicle, walking, and increasingly on public transit. The world is indebted to the London Data Store for convincing the English government that data collected by public organizations should be made public. Over 500 cities worldwide have followed London's lead, including Boston. Data on public transit systems has allowed the creation of public transit applications. Applications such as Google Maps and Nextbus have made navigating cities much more convenient for those who can access them. However, what about those who cannot afford to access them? Not everyone has the money to buy a smartphone. What can be done in order to provide a larger group with access to this public data? The ultimate goal of this proposal is to shift what is currently privileged information into its rightful place, the public domain. How can this be accomplished? Well, what if there were a publicly accessible object that could inform citizens when the next train or bus would arrive? What if that object could give you directions, or even inform you of a delayed or broken down transit vehicle? To this end, I have developed an idea called the City Positioning System, or CPS. CPS would provide public transit users without smartphones many of the navigational benefits only available today on smartphones or personal computers. In developing the CPS, there were two main requirements in order to end up with a viable product. The first was ease of use for a wide range of the public, and the second, a low cost in order to be able to be implemented on a large scale. In 1992, Durrell Bishop developed the marble answering machine. This example of physical computing is shown here. Each marble records two pieces of information, the message and the phone number associated with that message. These can be accessed by placing them in a sensor in the answering machine, or on the phone to return the call. Delivering information via physical computing is easy for the user to access and is generally cost-effective. While physical computing displays have great benefits, in order to be relevant in this situation, a display must incorporate digitally inputted real-time information. Fortunately, the City of Boston has made real-time data on trains and buses available via the Massachusetts Bay Transit Authority website. The CPS display will transform the data it receives into an easy-to-understand physical computing interface. The interface will employ a combination of rotating displays, push buttons, magnifying devices, LED lights, and stepper motors controlled by a small computer called an Arduino, in order to provide the user with up-to-the-minute directions for their travel. In order to test out my idea, I developed a prototype. Here are a few iterations that changed with my understanding of the technology that I could realistically afford and use. This is the final prototype. Its wooden housing protects the inner workings of the system. This diagram shows how the system is wired. Push buttons assigned to each stop return a signal that informs the stepper motors how far to turn based on the user's desired destination. Each of the three stepper motors turns a belt with different values printed on them. The first gives the user their stop, the second, their direction of travel, and the third, the train they should take. CPS is a device that hopes to radically improve use of the T for a large demographic within the city. According to Business Insider, as of September 2012, over half the U.S. population owned a smartphone. That number is likely still rising, but leaves around 40% of the population in the United States without ready access to public transport data. Boston should be interested in serving this sector of the population by increasing their potential mobility. This sector of the population includes a hardworking single parent, hoping to run a quick errand before the next train arrives. It also includes an elderly person who may be intimidated by digital and touchscreen displays. Finally, it can also serve as a tool for foreign tourists who may not have access to their usual data plan while visiting Boston. Though it may be seen as a small step, providing those without access to smartphones this high level of information will increase the upward mobility of many by making it easier to navigate larger portions of the city. While the benefits to Boston, its citizens, and of course the MBTA are numerous, the city positioning system has even greater potential in other parts of the world. In the major cities of developing countries, where the income gap is great, smartphones are rare if the 3G network has even been set up. The city positioning has the potential to democratize the dissemination of public transit data around the world.